Well, here we go. The second experiment. This time the TAs are going to do the work and I get to do the talking. I guess Dave was feeling pretty creative and doing some nice slow motion video of Ed there, who's swapping out the tensile jaws that we used in the last experiment. You just pull those pins out and then we can take the jaws out and then put in what are called compression platens. And now the actual start of the experiment, as usual, they're demonstrating good safety. Closed-toed shoes, long pants, masks, safety glasses. The compression one has potential for a little more eye damage, so it's probably good that they're actually wearing their glasses. There's the 4 specimens. Acrylic, wood, and steel are the pieces we'll test. We log in as students. There's no password as usual. It's important to pick the right method. That's the .mss file. You shouldn't have to play with that much, but the MSS file is just the instructions to the controller, how fast to move the crosshead, when to stop the crosshead, what the fail-safes are. So he opens the SMT, the Structural Material Testing Lab, compression wood. Now there's a piece of wood. You can think of wood as a bundle of straws, and in this situation he's putting the wood down on the platen such that the straws are horizontal. And I guess we're revisiting that one. The straws are horizontal, and the load will be applied vertically. So think of that as just a bunch of straws made out of cellulose, and they're held together by a bunch of lignin. Understanding the structure of a material is important. Okay, so Rahul is lowering the crosshead down, getting it close to where it needs to be, and of course you always zero out the load, right? Because there's some weight. We see there's a little tensile load there, so just from the springs pushing and adjusting, temperature drift, you always want to zero that load when you know there's actually no load. There's of course weight from the platen, but that's not an actual load on the specimens. He measures it, and in hindsight we can't really see this very well, but it looks like it's almost exactly 0.899, 0.895, something like that. But nearly 0.9 inches per side, a nice cube of wood. I don't actually know where we get these. Jacob, the Structures Lab manager, orders these for us. So Rahul sets it in the middle of the platens with the grain, the straws going sideways. Zeroes the load cell again just to be safe. Puts the handset in local mode and lowers it down. Zeroes the load cell one more time. And using the handset lowers it down. It's very important that only one person does this, right? You don't want your fingers in there while someone else is attempting to lower it. He's going to get it really close, but not quite touching. I'm not sure if he has it in high gear or low gear right now, but Rahul's done this literally hundreds of times. So there's still no load, so he thinks he can lower it just a little bit more. Now he's using the thumb wheel to make little tiny adjustments. Remember, he's only adjusting the position. And when that top platen comes into contact with the wood specimen, we'll see some load. Sure enough, there he's got very nice adjustment, 2 pounds, 2.8 pounds of load. And that's a real load. It is now in compression.
So that the experiment can start at 0, 0.
Now he's ready to hit play on the wood compression method. Again, that's just a set of instructions that we give the controller. And of course, classic mistake, you leave the handset in local mode. So even Rahul, who's done this 100 times, forgets. Now he hits play, asks for a sample ID. Name it something good. Name it Rahul, wood, horizontal. I can't really read what the text says there, but please give your sample IDs some informative name so that a month from now you might remember what it is. We'll enter the dimensions that he discovered. I think it's 0.9 inches on its side. I still can't really read that very well, but I'm going to assume that's what it is. And now three last reminders, and Rahul gives us a thumbs up and hits play. We can see that very quickly we're only at about 1/100th of an inch, and we've already got 800 pounds. So it's fairly stiff stuff. And it's fun to simultaneously watch the sample in the lower right-hand corner. And then the loads. We're up to 1,000 pounds. Very quickly the load went up. The crosshead continues to move. We're now at 800ths of an inch, 900ths of an inch, almost 1/10 of an inch. But the load is kind of flattened off around 900 pounds. Still pretty impressive though, that we could take you and 5 of your best friends and you could all stand on that little piece of wood. And it would support your weight. Right, so it gives you a sense of how overbuilt most wood structures are. And now I can barely read that, but 1,100 pounds, 1,200 pounds. Still climbing slightly. Now remember, the crosshead is moving at a constant rate, right? What this machine does, it moves, yeah, thanks, Rahul. The crosshead moves at a constant rate, and the load is just a result of the elastic properties of the material. Now we're up to 1,200 pounds, right? So it climbed very quickly, and then something happened within the structure of this material that it's no longer supporting much more load. So it's very stiff at first, and then now it's becoming slightly more compliant. And it could be that, oh, okay, now it stopped. I guess we reached 0.3 of an inch, 0.3 inches, and that tells the controller, again, that's part of the .mss file, and we can see that shape. Right? So he's released the platen, and he's looking at that, and then now let's see if we can figure out, just by examining this chunk of wood, focus. Yeah, so it looks like this bundle of straws, the glue holding the straws together kind of slipped. You can see there's maybe 2 or 3 planes on which it looked like the growth rings from when that wood was growing. That's where it slipped. He goes to File, Export, Preview, Specimen. Don't just save. Saving just saves the method. You have to go to File, Export, Preview, Specimen, and that generates this text file that you need to save. Save the text file, not the instructions. And Rahul is very good at saving this in a good location. It's his little personal folder on that particular computer. And he's going to name it with an intelligent file, like wood horizontal test 1 or something like that. Rahul wood. Again, I can't read that while I do the voiceover. But a nicely performed compression experiment on this wood. Now he's got the data saved as text. Probably need to convert that to a comma-separated variable file, CSV. All right, Rahul. Thanks, man.